about this in foundations, but if not, it's fine to chat about the reminder. Like, you can have snacks in class, but if it's right after lunch or like right after breakfast, like you should have eaten food in the cafeteria, right? Because we got to do class. All right, so 711 is due today. If you don't have it, it is okay, but you need to put it on your to-do list then so you don't forget about it. So guys, if your 711 isn't done and ready to turn in today, it should get written down in your plan book to-do list. It is going to be late. It is going to go in math. Now, some of you, I got a ton of stuff to pass back. Luckily, I remembered from most of your class. Some of you still owe me the closure and even 627. Like half of us still need to turn in the closure. So guys, here when we get done checking the homework, let's make sure if you have 627 or the closure to turn in, turn those in, because I haven't put those in map yet. Because right now I would be putting in more missings than I would checks. Right? And we did closure together in class. So guys, it's okay. We all make mistakes, but if you are behind on homework, I bet you had time this weekend that you could have done it. So step it up and do your work. It's not the end of the school year yet. Questions on 711? Things we could not do. We can go back to that slide, but it's 712 is today's homework. We'll hang out on this slide for a second while people fill it in. So if you don't have 711 done, that's also homework for tonight, really. How about this? I will take at least 60 seconds, right? To stop talking. If you need to turn work in, turn it in. If you need to fill in your plan book, fill it in. I cannot show you homework answers at the same time. I can try, actually. So here's your plan book for the week. Stuff is due 2 days later. It's very hard for me to show both. There's most of the homework answers. That was easier to find sitting like this. Alright, are we good on plan book? Good on plan book? It's fairly simple, except Thursday we're going to try to combine 2 lessons. So I will probably tell you specific homework problems to do. Alright, there's 711. Please let me know if we have questions. Yeah. Am I crazy or do we not have Jesus here today? Yeah, he's not here. 7:15. And in just a second. I guess since there's some few people sitting up front. Yeah, I was about to, I can also just set them there for the time. Tough weekend. It also just feels very different with the desks like this, right? So in 15, a couple people came to ask me about this, and I appreciate those of you that identified that it was hard and were doing your work on time and decided to come get help. But I put the shape in here like this on purpose because we could have shown the shape like this and essentially made you solve it like a trapezoid. But seeing it the way we see it, we have the option of we could solve it like a trapezoid or we could solve it like a triangle. So if I make that part of the shape one shape and this part the other one, what do I really have?
16 and 7.
Yeah, a triangle and a square. So my area of my square is 4 times 4, or 16 feet squared. Area of our triangle. Now this is where it gets tricky and some of us are still struggling. It's base times height divided by 2, where base and height have to be perpendicular with each other. So we have those little squares in the corners that tell us that those are our base and height edges. It doesn't matter which one we use for which, but we've got a 4 and a 3, right? Because if this bottom side is 4, this is also 4. So 4 times 3. What is 4 times 3? 12 divided by 2. So we've got 16 feet squared and 6 feet squared. Now, if we took it all together as a trapezoid, what we would have to identify is that the bases are parallel with each other, and the height is the distance between the bases. So, if we took it like a trapezoid, it would have been base 1 plus base 2. I like to do base 1 as the smaller one. So what would the bigger one be? Well, if this is 4, this is 4, making the whole side 7. Those get divided by 2, and then we multiply by the height of 4. Either way that we take, when we add them up, or when we do this math, what will our total area be? No, wait, what's 16 plus 6? I think it's 22 for our area. And then feet squared. Eve showing up for math class. I love it. Thank you, Eve. So, 22 feet squared. But then, if we had applied our scale factor, now this is where it gets weird. The area does not just do times 2.5. So when we look at the answer key here, we see the new area is way different. Because guys, if you scale it up, and I'm not going to do this for you, then find the perimeter and area of the original and enlarged, we have to imagine or draw it out if we enlarge by a scale factor of 2.5. Guys, we got to read our work and do what it actually asks. So if I was you, I'd probably have a sketch of the bigger one, or maybe on graph paper or something like that. Other questions? Other questions? All right, well, this is on the YouTube video for today's lesson if you want to go back and check it. So today we're doing 712. If 711 is done or anything else is done, turn it in. And then we need 712 out. Oh, my bad. Also, I think somebody came in here this morning and found a bunch of stuff. And found it hiding over there behind my desk. If you don't have 712, it is right there. Alright, so reminder, because I don't like you guys being surprised, I am out on Friday. So you will have a sub. You've had this guest teacher before, so no big deal. Mr. Lifel. I forget how. I don't say his last name very often because we're friends and I normally use his first name, so I forget how you actually pronounce it. I mainly just know him by his first name. Alright, so first things first, let's double check that we all still have this math notes packet. So guys, on the start slide, I can't remember where Smart is. Oh, it's back here. When it says math notes packet, that's this, right? So everyone get this out. I want to make sure that you still have it. I want to make sure that your name is on it. Anybody that wasn't here, like maybe you were absent, I want to make sure that we all have this. You don't have one? That is why we're doing this. Make sure your name is on that. There we go. And then fold, flip, whatever you want to say, to like the second couple pages here. The math notes box from today's lesson like at the end of the lesson, is actually the quartiles and interquartile range box. So I'm going to take a second to go over this, because I feel like we always run out of class time, because I'm always solving problems all the way up till the end. But the thing that we reviewed today that I would maybe take a highlighter to is our quartiles and interquartile range section. Guys, I will be very honest with you. I memorized this when I learned it. I did not understand what it meant. And then at a certain point, I was like, oh, I'm an idiot. Why didn't I know that? Like, because nobody ever explained it. So let's talk about this. What does quart mean? 4. So quartiles, if you get a quart of milk, it means that it's a fourth of a gallon. So the prefix quar, as in quarter, means 4 equal parts. Quartiles are making your numbers into 4 equal parts. So what we're actually doing is taking an entire set of numbers. First things first, we got to put them in order from smallest to biggest. First things first. I'm not even going to talk about first quartile, second quartile. Like, we're not there yet. First things first, you put them in order. Then we find the median of the entire set, and this splits us into 2 halves. So we find the median of the... Now, what's median? Middle. And if you need to make yourself a reminder, write that reminder off to the... Oh, I don't have any pink pens. Where'd my pink pens go? Maybe I'll just have to use orange. When we split into 2 halves, we use the median. That's our middle. Guys, is anyone lost? This is on like page 3 of the packet, if you will. Like, I see some people not moving at all. You're kind of sitting there, like, just doing nothing. I'm trying to give you the chance to actually understand this stuff. Oh, by the way, thanks to Amanda, we have some extra highlighters over there now. Her mom's donating some stuff. So those of you that have been taking my highlighters out of here, 1, please stop, because we're running out of highlighters. But please use them while you're in here. So then, guys, and this is the part that nobody ever explained to me. Next, we do everything again. We find the median of the lower and of the upper halves. All right, so now for a second, hands off, eyes up here. What? What do you mean? The thing I just said that maybe I'm going to make you watch, which is why I said hands off, eyes up here. So as long as hands off, eyes up here makes sense, you're okay. We okay? Eyes up here. Here's my data. 22, 43, 14, 7, 2, blah, 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 blah. It's not in order because math is annoying and they almost never give it to us in order. So start by putting it in order. So if I use the note space, I would have it listed out 2, 7, 9, 12, 14, 22, 32, 36, 43. There are 7 numbers, which I double check. 1, 2, 3, 4, 5, 6, 7. Wait a minute. 8, 9. Oh, wait. 4, 4, 1. Okay, I got 9 numbers. So do I have 9 numbers from the beginning and from when I put them in order? Sweet. 9 numbers. We're good. Now, with them all lined up, 9 numbers splits in half nicely. So when we find the median of the entire set, 14 is going to be that median. So guys, if you need to, right up here, write your numbers out. 2, 7, 9, 12, 14, 22, 32. You don't have to because they're already listed out beneath you, but if you want to, or beneath here. 14 is gone. It's like out of my set now. I don't talk about it in the lower half. I don't talk about it in the upper half. It was my median. It like got used. Now my lower half is 2, 7, 9, and 12. Questions about that? My upper half is 22, 32, 36, 43. Lower numbers, higher numbers. Then, to find what we call the first quartile, where we split into fourths, right, quartile, we find the middle of the lower half. But the problem is there a middle of 4 numbers? Not really. There's like 2 and 2. So we have to actually figure out what would be between. What would be in the middle of these 2 numbers? What's between 7 and 9? 8. So even though 8 is not in the original data, my phone is vibrating and it's messing with my camera, I feel like. Even though 8 is not part of our original data, 8 is what we call our first quartile. And that's what tends to confuse kids is, wait, where did that number come from? It's the middle of that lower set. We do it again over here with the third quartile, so try it on your own. So what number is in between 32 and 36? 34. So 34 becomes our third quartile. And this also confuses kids. The median, the 14, that is also what we call quartile 2, because it's right in the middle. There are not 4 of these numbers, because this breaks it up into 4 sections. So now we have, I mean, that's a really good question, so thank you for asking it. Now we have like section 1, section 2, section 3, section 4. But to split it into 4 groups, we only need 3 checkpoints. I'm going to write it all out to make sure it makes sense. And this is one time that I'm not actually going to use graph paper. See what page doesn't have numbers on it. So if I write out my data again, because guys, I kind of just want you to watch this. 2, 7, 9, 12, 14, 22, 32, 36, 43, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got my 9 numbers written out. The first thing we do, guys, if you could not right now find this, do this, whatever, like you should watch. First thing we do with 9 numbers is say, okay, 4 on bottom, 4 on top. What is the middle number? What is my median? My median is 14 splitting into my bottom half and my upper half. Right? All I've done right now is split my numbers in half. This is what we call quartile 2. Now, with my lower half, I have to find the middle of those numbers. But because it's an even amount of numbers, it's annoying. It's not nice. So what's the middle of 4 numbers? Well, the middle of here. So quartile 1 becomes 8. Same thing with the upper set. So since there are 4 numbers, it's annoying. Where's the middle? Between 2 numbers, quartile 3 is 34. Now, when we go to turn that into a box and whisker plot, and guys, I'm just going to draw this to match my paper. This is not necessarily how it would draw on a number line. Quartile 1 and quartile 3 are the edges of the box. Quartile 2, or your median, is the middle of the box. So quartile 1 goes here, quartile 2 goes here, quartile 3 goes here, meaning this is 8. This is 14. This is 34. And then what goes on the edges of the box? It's a box and whisker. Where does my data end? What's my lowest number? 2. Where does my data stop at the top? 43. This is how we do quartiles and interquartile range and turn them into a box and whisker plot. So that is in your math notes. If you want to write anything else down for it, you can always add to your math notes. You can put post-it notes on here or whatever. But guys, this packet, you're going to have like forever. This is yours to keep. write, highlight, do whatever you want with it. But there should be no if you bring me a question like this, I'm going to ask to see your math notes. I'm going to ask if you've looked at this. Okay? We all cool? All right. Now we got to do a couple of questions on the lesson. So 712, you need it out on your desk. This example with Dana. All right, anyone want to read for us since I've been talking for a long time? John, you want to read our situation with Dana?
Dana is training for a bicycle race. He can ride his bike 25 miles per hour. One day, when he had been riding for 3/5 of an hour, he had to stop and fix a flat tire. How many miles had he ridden when he stopped?
All right, so I want you, and I know you're not really naturally sitting in groups right now, and maybe we'll shove some desks around. Talk with people near you, or just, think about it on your paper, try it out. How can we figure out how far Dana has ridden if he's ridden 3/5 of an hour? And we know he goes 25 miles per hour. All right, so go ahead and start talking with each other. I might start scooching desks. Gonna switch desks. There's sort of like a Meineke method here. There are two great ways to do this. Probably more. So, we're talking about fits. If you need to know how far they can go, well, so that's 3 fifths, right? Let's make sure we observe everything, read everything. So that is showing 3/5 of 1 total hour, right? So this is just 1 hour. Here to here, 1 hour. So this is a little over half. So if we're going to work with 3/5, 1 try first with that one up. Okay.
No, 75. So then 75 so 5 5 is 10. So yeah, 15. So 15 times 5 times 15.
Oh yeah, we committed to going through all the cards before we... Alright, I think some of us are stuck, so we should probably bring it back together. Now, did I call on you last week? Okay, maybe you just ended up talking, but you were on top. So I'm going by cards, but your card is on top. Okay. Alright, John, give us one way, because we said there are at least 2 great ways that we can do this.
This is the way that me and Vincent did.
This is the way.
Okay. We started with putting 25 miles over 1 hour. No, we didn't do that. We just put 25 over 1.
Okay.
Since it's that, if you multiply that by 3/5, you get what 3/5 of 25 is. So that would equal 75 fifths, which if you turn that into...
So wait, you're saying multiply by 3/5 on top and on bottom, or multiply by 3 over?
3/5.
Ah.
Yeah. 3 over 5.
So wait, I think why they're doing this, and help me if this is not right, but I think you're setting up 3/5 of an hour and 3/5 of, what does of tell us to do?
Multiply, which, if you multiply those together, you get 75 fifths. And then how many 5 5s going to 75? You got your answer.
How many 5s going to 75?
15.
15.
And then if you want to double check that, you can do 15 times 5.
So they're saying this section here, how much he has ridden before he had to stop and fix a flat tire is 15 miles. Guys, does it make sense that it's less than how far he can go in 1 hour? Yeah, that makes sense. Now what's funny is I think you and Vincent work together, and this is not the way I anticipated you guys to go, because there's kind of like what you did on the percent problems we had, but maybe it's just not jumping out at you. Lucas, do you have another way?
Yeah, I did it a different way.
So this is totally right, by the way, and 15 is the answer. But if that way didn't make sense, that's fine. There are lots of ways to do this. So Lucas?
So I made a fraction, 25 miles over 60 minutes.
25 miles over 60 minutes. Now wait, where did 60 minutes come from?
60 minutes is equivalent to 1 hour.
Oh, hey guys, we don't have to use the label they gave us. Lucas is like, what I want to use is minutes, so I'm going to switch this. I know 60 minutes is an hour. Any question here? Okay, keep going.
And then I divided both, divided by 5 over 5. It's to 5 miles over 6 minutes. That is equivalent to 1/5.
5 miles in how many minutes?
6 minutes. And that's
Wait,
1/5.
60 divided by,
Oh. Close.
I think 60 divided by 12, or 5 gets us 12 minutes.
Yeah, I was close.
So either that or you divided by 10?
But then that way it 5. So, yeah, that's 1/5.
So, hold on, I want to go to the number line. I agree with where you're headed, but guys, I think we're making this harder than we need to. Eli?
Actually, what I did was I figured out the time first, so I put 60 minutes for 1 hour. And,
So I'm going to write or 60 minutes here.
and I divided by 5.
So you divided by 5. Hey, stick with us here because I think Eli's going to take the way that my brain thinks. You divided by 5.
And that equals 12.
You got 12. Now, is that the only thing you divided by 5?
Yeah, right now.
Okay.
And then I did, so that equals 12 minutes for 1/5.
So you're saying this right here would be 12 minutes.
The minus method. Except it's not 10%, it's
And then I times it by 3, which equals 36 minutes.
Okay.
So 36 minutes would be 3/5. So then I just did divided the 25. Wait, okay.
So you did a couple extra steps because we don't actually need this. Like, this is right. What Eli just said is right. But what do I care about? I care how many miles. Right? I know the 3/5. So guys, if you haven't done this on your paper, take 25 and divide it by 5. 25 miles. Why am I doing that? Bar?
The whole is 25 miles, but there's also 5 spaces.
There are 5 spaces here. What we are talking about is fifths of the thing we know. So this 5 miles tells me that every fifth, every section of the number line, every this is 5 miles. Are there questions on how I did 25 split into fifths, so divide by 5, and got 5 miles? Any questions on how I got to this 5? So then, I'm not just looking for one section, I'm looking for 3. So we multiply by 3 and get 15. But there are tons of ways to do this, right? All of us had like a bunch of different ways to think about it. But this should be 15 miles. Vincent?
That's how I originally thought about it, and then I didn't realize like how that would work with the fraction thing.
Yeah.
I just was like divide by 5 times 3 is 15.
So really the trick is see if like the denominator works nice or plays nice with the other numbers we're dealing with, right? Because 25 divided by 5, that's just about the nicest thing we got up here. Because even like 60 divided by 5 to get 12, that's not super nice. Let's try another one like this, but this is not on your paper. If you're trying to go from an original shape, this is not on your paper, so either graph paper or some other leftover paper from last week or something.
Well, we know 3/5 of 25 is 15, so if you multiply it by
You want to announce every plot point of the movie?
yes.
And then that character gets together with that character, and they live happily ever after. If we're going to try to write this as an equation to look at how we scale, it's the same on purpose because now we're doing more with it. What we're going to say here is Matt's new shape is 3/5 of the original. We can abbreviate original. So Matt's new shape is 3/5 of the original. He is scaling down. So if we're looking for the new length, we set up math that some people told us to on the last slide. The new length. I want to change colors. I like green for new. Well, what is the original that we're trying to scale? 25 up here, right? So if I already have a fraction, what's nicer to work with a fraction? Another fraction. So 25 can turn into a fraction by going over top of 1, because 1 on bottom doesn't do anything. How do we multiply fractions? Straight through, right? Straight across the top, straight across the bottom. And either, if you can recognize that these numbers play nice with each other, they actually do play nice because this is like 50 and 25. If I can break this number up. Or we almost always have a calculator. But I can think, I know this is bigger than 10, because I got more than 50, right? And we know from the last slide, like John already announced, yes, we know that this should turn into 15. Now we could probably start, isn't Jaden Smith acting now? Or is that, who's Will Smith's kid? Like, and one of them sells, like, boxed water or something. Can you what? I mean, don't we normally get off topic at least once every class?
What's your favorite Spider-Man?
Oh, that's not a quick question at all.
It is.
Alright, so I'm debating how much time we have left and what's on your paper. Let's go to 19. Because this is more important, because this is the stuff that you're going to do in your life probably like once a week or maybe once a month. Give me the look like you're never going to go out to eat.
No, I'm not. Food or
I guarantee that at some point you will get tired of cooking, or you will want to like not have the stress of it, and you will go out to eat. All right, here's the deal. We do a lot of stuff wrong in this country, one of which being if you are a server at a restaurant or if you work a tippable position, you get paid squat. You get paid, like, it's sad how little we pay people, so we tip them, right? So if they give you a service, if they do something for you, we tip them. When you travel, if you travel, hopefully when you travel, you'll notice other countries don't tip. It's different depending on where you go. So, if we go out to an Indian restaurant, who's eating Indian food? Who likes Indian food? Because sometimes it's too spicy for kids. Yeah, I love it. and our bill was $38, and we want to tip 15%. So guys, is leaving a tip going to cause us to spend more or spend less? Spend more, but you're doing it because they don't get paid enough, right? So it's like a societal thing. We tip in America.
Wait, do they get the money?
Yeah, you like leave it on the table, they pick it up. Sometimes they share among like all of the people at the restaurant. Sometimes it's just for them. I mean, it depends on the place. And sometimes they have to pay taxes on that as well. Because, if they make a ton of that's getting in the weeds of like what we need to discuss here. But I want you to chat real quick, maybe like a minute or two with your team. If we're trying to find 15%, how could we do this? Go. And there are multiple ways.
Bill is $38.
You have to bill what you have to pay.
Oh, I thought Bill was a guy.
No, the bill. The bill is $38. Yep. It's like an insult. Yeah. Hey, focus. So you got 15% and 20% and all of everything and your homework's done? Maybe we need to read. All right, Vincent, funny that your card is next on here. If $38 is my bill I have to pay, what percent is that? That is our 100%. If we were going to start to solve percent problems, what might be another percent that's nice that we could find? 10. A 10%. Now, how might we find 10%? Divide by 10. Like a young person told us earlier in the year. They seemed very brilliant. I think we even named a method off of them. So guys, when we divide by 10, what we do is grab the decimal and move it over one spot. So now we have 3.8, or since it's money, we could say $3.80.
What's 3.8 divided by 2?
Now hold on. Why are you asking that, John?
Because we need a 5%.
Why do we need 5%?
The 10 and the 5.
If we're looking for 15%, right, ignore what this says down here because that's a different problem. I just needed space. We want 15%. So we want 10% and we want 5%. How do we go from 10% to 5%?
Divide by 2.
Divide by 2. Now break this up because it is kind of hard. What's $3 divided by 2?
$1.50.
$1.50. What's 80 cents divided by 2?
40.
So what's $1.50 plus another 40 cents?
$1.90.
$1.90. So what would our 15% be? Well, we got to add these together. So $3, $4, $5. Anyone got it before me? $5.70. Now, actually, we start thinking about what Mr. Hudson told us back in middle school and how people don't get paid enough. And we decide, actually, instead of leaving 15%, we decide we're going to bump it up and leave 20%. How can I use what I've already done to find 20%? Kylie? We could add another 5% or multiply the 10% by 2. Double that. Since we had it, use it, double it. Either way. Now, there is another way to do this if we have a calculator, which you'll normally have your cell phone. Hang on real quick, John. So I'm trying to squeeze it in before the end of class. Guys, here's the other way. I want to clear this ink real quick, although everything we did was really good. Actually, kind of like that. Here's the other way. What does 15% mean? Percent. What does percent mean? Per 100. So 15%. Hey, give me your eyes up here. I don't need you to write this. But I do want you to. We'll probably pick up on this problem tomorrow, like to start class. But hang on. Quit packing up. Those of you that I see trying to sneak there. 15%. 15 out of 100. 15 hundredths can also be written 0.15.
That's what I did.
You could just do 0.15 times, what am I trying to find 15% of?
38.
The 38. And that will give us the tip that we're looking for, assuming that I have a calculator, right? And I can just plug this into a calculator. All right, that's all the time I got. We'll pick up here tomorrow. There's always multiple ways. All right, have a good day, guys. Happy Monday. Yeah, I'm not sure about math lunch. If you come here and my door is shut with a sign on it, I decided to go outside. Yeah, I'm thinking today might be too tempting. Maybe I should just go outside.
Yeah, I'm going outside today. I was going to have some kids work in my room, but I'm like, no, it's too
I was thinking about claiming a couple picnic tables for like work area, but I don't know how outside looks right now. You know, like of where people sit for lunch or whatever.
Friday, it was 8 packed out there.